So let's talk about these efficacy outcomes you guys maybe had some issues with in class today. So let's start out with some lay of the land. Your experimental versus your controlled event rate. So your experimental event rate, that's what the EER stands for, is the percentage of time something occurs in the experimental group. The controlled event rate is the same, only it's for the controlled group. So your relative risk, or your risk ratio, also known as RR, is really just the probability that something's going to occur in the experimental group versus the controlled group. If it's greater than 1, it means that it occurs more frequently, and that would make sense because they would have a higher number in the higher part of this fraction versus in the denominator. If it's equal to 1, then it's equal. And then if it's less than 1, then of course it's less likely to occur. So, let's start out by trying to calculate your relative risk or your risk ratio. Going back to our trial here, so if you remember, this technically is sacubitril, valsartan, and this is your experimental group. And you would just know that by reading through the trial, knowing what we're trying to study here. Enalapril is the controlled group. Now, looking at this primary composite outcome of death from cardiovascular causes or first hospitalization for worsening heart failure. So this is a composite outcome because it has two different things that are occurring at once. Versus this, death from cardiovascular cause would be a single outcome. So this composite outcome of death from cardiovascular causes or first hospitalization for heart failure, we look and try to figure out which is our controlled event rate. So CER would be here because this is your control group and this is the event rate. So this is a percentage, 26.5. We can change it into decimal form and put 0.265. Experimental group is over here. You'll note that this is the rate, and we can also put this into decimal form. And it might be best practices to go ahead and just use the decimal form as you're doing these calculations so that it comes a little bit easier whenever it comes time to do the number needed to treat. So let's go ahead and try to calculate relative risk, or the risk ratio. As I mentioned before, it's the EER divided by the CER, which equals 0.218, which we decided was our EER, divided by our CER, which is 265. Now, if I were to plug and chug this into my handy-dandy calculator, I should get 0.8226. This can also be converted back into a percentage form, which would be 82.26. So what this means is that if I am in the group that got sacubitril valsartan, I am 82% likely to have a composite outcome of death from cardiovascular causes or a heart failure, a hospitalization due to worsening heart failure, than my group, the CER. So it's just saying this is the proportion that it occurred in each group. Now, absolute risk reduction is the difference in the rates between the two groups. So you're going to take your CER and subtract it from your EER. And for trials like this makes sense because your CER is higher than your EER. So let's try that one. So ARR equals your CER minus your EER. Okay, so what we should do here is we're going to take that CER, which we already decided was 0.265. We saw that here. Subtract it from our EER, which is 0.218. If I subtract these two, I should get 0.047. We can also change this back into percentage for it, and then this would be 4.7%. So overall, the difference in the rates between the two groups was 4.7%. Now, what our next one is our relative risk reduction, or RRR. This is the most commonly documented thing in clinical trials, and we're going to see why just in a moment. So this is how much your risk is reduced by having said therapy. So let's go ahead and calculate it. So there's two different ways we can calculate it. It's ARR divided by your CER, or it's 1 minus your RR. So if we do it this way, the ARR divided by the CER, we've already calculated our ARR, so it was 0.265 minus 0.218. We got 0.4047, and that would be over our CER, which is 0.265, 0.265. And then what we should have got there is 0.1773, which is approximately 18, or 0.18, or 18%. So what we're saying with this number is that if I take sacubitril/valsartan, my risk of having a cardiovascular death or hospitalization for worsening heart failure is decreased by 18%. Now, you can see why this is a very tempting thing for a clinical trial to report compared to only saying there's a 4% absolute reduction. In order to try to get over this clinical trial stuff and try to come up with a more objective term, we often use number needed to treat. So that equals 1 divided ARR. So this is the number of patients you need to treat to prevent one event, and this helps to estimate the treatment effect. So let's go back to our current EER and CER. So let's do number needed to treat equals 1 divided by ARR, which equals 1 over your controlled rate minus 0.218, which is our event rate. So that's 1 over 0.047. And I believe I get 21.28. Now, mathematically speaking, it's very, very tempting to say, you know what? That rounds down. I know this. My mom was a math teacher. Anything above 0.5 rounds up. Anything below 0.5 rounds down. However, because we're talking about number needed to treat, we never want to give the trial the benefit of the doubt. So what we're going to do is we actually round up. So we're going to go to 22. An easy way to remember this is if I just kept making a line through this T and number needed to treat, or did it lowercase, that's a plus sign. So we're going to add 1. And the reason that we don't just keep it in decimal form, because there's no such thing as 2.8 of a patient. So this is the reason why we want to go ahead and round up. Now let's do some of the safety calculations. Now, I think of attributable risk as the evil mustachioed version of relative absolute risk reduction, because it's calculated very similarly. The only difference is that we put our event rate first and subtract it from the controlled rate, where your EER is subtracted from your CER. Now, we use this primarily on adverse event calculations. So let's look back at our trial. Now note, some of these adverse events are not statistically significantly different. So I could not calculate it on your elevated serum creatinines, your elevated serum potassium here, angioedema, any of these, because it has to be a nominal value, statistically significant, and meet superiority. So this hits all these criteria. So for this one, our EER is going to be 14 or 0.14, and our CER is 9.2 or 0.092. So let's try some calculations. So your attributable risk, as I mentioned before, is the evil mustachioed version of the absolute risk reduction. So it's just a subtraction where I'm going to say your ER is subtracted from your CER. And for us, our EER was 0.14, our CER was 0.92. And you guys can see where I got those. So I went ahead and kept them in the decimal form. What I got here is 0.048. And then we're going to do the number needed to harm, which again is the evil mustachioed version of number needed to treat. And this is the number of patients need to be exposed before they can have one adverse effect. So your number needed to harm equals 1 divided by your attributable risk. 1 divided by 0.14 minus 0.092, which we just calculated up here, 0.048, which equals 20.83. And I think this repeats. Now again, it's very tempting to round this up. However, we never give drugs the benefit of the doubt. It looks worse for a drug to have to use one less patient in order to have an adverse effect versus one more patient. That doesn't give the drug the benefit of the doubt. You can kind of remember this by looking at number needed to harm. In the middle of it has a minus sign, so I always go down. So that means that our number needed to harm is 20. So a brief overview. We went through relative risk ratio, or risk ratio. This was just a division of your EER divided by your CER. We went through relative risk reduction, which is either ARR divided by CER, or 1 minus RR. We went through ARR, or your absolute risk reduction, and its evil mustachioed cousin, AR. The only difference here being the event rate is usually higher whenever we're studying a new therapy. So that gets subtracted from the CER, and the CER gets subtracted from the ARR because usually the event rate, or the EER, because the event rate is usually higher in the controlled group when we talk about clinical trials and the efficacy outcome. And then finally we learned how to calculate number needed to harm and number needed to treat. Number needed to treat always gets rounded up because it has that plus sign in it. And so that's 1 divided by ARR. And then number needed to harm equals 1 divided by AR, which is always rounded down because it has a minus sign within it. If you guys have any more questions, let me know. If you guys want any more clarifications, I'd be happy to help you out. If you want some extra practice, you can always go back through and try to calculate them on some of these other values, such as systemic systolic blood pressure of less than 90, or going back to this, you can always calculate on any of these outcomes that are statistically significant. That being said, that is all I have for you guys today, and again, just ask me questions if you have them.